I will turn. My camera is not working, so if I can get it to turn on, then I will do that. But my computer is whack sometimes, I swear.
All right.
I'm also making egg salad, so I might have to get up in a second and drain the water out. I thought I was going to have more time before our meeting, but I didn't.
No worries.
All right.
We forgive you.
Thank you. I really appreciate it. And I was watching, I don't know, do you guys watch This Is Us, that show?
Everyone
Nope.
watches it. I haven't watched it.
Oh my heck. It is so good, but I shouldn't have started watching it before because I was getting all emotional. I'm like, I got to stop this before our quiz because otherwise I'm going to be sobbing and everyone's going to be like, what is going on?
So funny.
Okay. So,
All right, I am in the quiz. How many questions do we have today? 18 questions. Great.
Oh
Holy moly.
this will definitely take us longer than a half hour.
no.
Gosh.
This looks really hard today.
Yeah, just a little bit.
This lesson was like really hard.
So the total area
Yeah.
on the distribution curve must equal, honestly, it needs to equal 1, right? Like something like that.
The
Question 3.
Yeah, I think it would equal 1. That would make the most sense.
Yeah, I think 1.
All right. Under certain circumstances, a normal distribution curve can drop below the x-axis. Is that possible?
I think it's false.
Yeah, that's false because the x-axis is the one that's flat, right?
1 second. I just have to drain the water from I'm listening to you. I'm in the kitchen.
Yeah, good. Question, can you hear my voice a lot clearer than before, or?
I can.
Like, is it more clear?
Yeah, it's a lot clearer.
Okay, that's because I'm in the radio station again. So I'm using all the fancy equipment. But that's good. All right, y'all ready?
Yep.
Question 5. A normal distribution curve is symmetric. What does that mean? Like it's a bell curve?
Same.
Symmetric, like the same on both sides? Is that...
Yeah. Can we can probably put true. I know that there are some distribution curves that aren't like that, but a normal distribution curve should be.
Right.
We're on 5, right?
Yeah.
Because like I've seen distribution curves where it's like got a tail, like it's right skewed or whatever, left skewed, but like a normal one is typically a bell curve.
I would say that that's true.
Yeah.
Yeah.
That's what we put.
Okay.
Which of the following elements of the figure represents the z-score? A, B, or C? I think it's C.
Yeah, I'm pretty positive it's C.
Well, did you guys click on that link?
Yeah, I did. The one that was in the lesson.
Yeah, and then kind of down below, it's got the z-score.
Yeah. It's so funny because I took because I'm a rec management major, and so I don't know what your guys' majors are, but I took a class last semester and it was like research and evaluation, and we had to deal with all like the histograms and the z-scores and like I don't know, all of this lesson basically centered around that, but I hadn't taken this class, so I like had to like self-teach myself. It was horrible.
Yeah. I had a math genius who's like a millionaire. I don't know why he was teaching at my school, but he taught me all this crap and I forgot it. Which of the following elements of the figure represents the probability that the z-score will be greater than 1.0? I think it's B.
B? I think it's B.
Because it has to be on the right side to be positive.
Yeah.
Or rather, it's got to
Right.
be closer.
No, I definitely think it's B.
According to the 68, 95, 99.7 rule, what percentage of the data from a bell-shaped distribution will be within one standard of the deviation of the mean? What's that supposed to mean? Write your answer as a percentage such as 42 rather than a proportion such as 0.42. One standard deviation away. Let's just say we do that.
Let me write it down.
Wait, let's see what that means. So it should be 68%, right? If it's one standard deviation away.
That's what I'm getting.
Okay. So you just put down 68 instead of 0.68.
Oh, do we need
Okay,
to put the percentage thing, or do we?
Yeah, it says right there. Write your answer as percentage such as 42 rather than a proportion such as point.
So don't put the percentage.
Don't put 0.42, right?
Yeah.
6.8 instead of 0.68.
You guys, so my thing kind of flaked out on me, so I'm still on number 5. Can you guys help me, please?
Oh, yeah.
What did you put?
You're on
Number
5.
Sorry.
So 5 was.
Yeah, because I got kicked out of the group.
Oh, I didn't see. Okay, 5 was true.
Okay.
6 we got C.
C.
Yeah.
7 was B, and 8 we decided it's 68.
68.
Oh boy, how are you guys getting these answers? Okay. 68.
Yeah, that's what we put.
Okay. Thank you.
Sweet. Ready to go? Question 9.
Yes, that
Suppose
is.
that z-scores come from a standard deviation standard normal distribution. Use the normal probability applet to solve this question. What proportion of the z-scores will be between -1 and 1? Right, your proportion of the z-scores will be determined what? What proportion?
Will
That
be
doesn't make any
between
sense. So are you trying
-1
to find the percentage or the z-score?
the z-score, I think.
The z-scores will be between -1 and 1.
Yeah, I think it's the z-score.
What does that mean, proportion?
What proportion of the z-score will be between? Like how? I don't know.
I'm looking. This thing is confusing. Where's the applet?
That doesn't make any sense.
I'm at my boyfriend's apartment because he has much better internet, and they're all snowboarding, but his one roommate is here, and he's gonna wake up and be like, "Why are you in my kitchen?" Sorry that my apartment's internet has been down since last night because I live at Nauvoo, and Nauvoo has like their own Wi-Fi,
Sure.
and it sucks.
Oh, that's stupid.
Did you go to the normal probability little page?
Applet thing. Looks like the next 3 questions have to do with that.
Yeah.
Yeah, but it doesn't make any sense.
Because it doesn't. I don't know.
It's like if you were to add the two together, -1 and 1 z-scores, it's 0.
Right.
But I don't think it's 0.
So.
Would you put like 2. I don't know.
What proportion of the z-scores will be between -1 and 1?
Well, here, how about we try this? We don't want area, we want z-score. Well, wouldn't the 1 technically be the standard deviation, not specifically the z-score? Or is that what the z-score is the standard deviation?
I don't know.
Okay, so now what I'd like to do is I'd like to talk about converting z-score to probability. Okay, so there are 2 different steps. Take the z-score to probability first. You get a z-score that
I'm looking too.
I'm so confused.
I'm really confused by this question.
Well, maybe we should continue on and come back to it.
Because then it says give your answer as a decimal.
Does anybody have any answers from the reading or whatever we were supposed to do before?
I'm like totally stumped.
Now I'd say, yeah.
All right, well, let's skip 9 through 11 and go to question 12 and come back to that later. And question
Okay.
12 says,
Look carefully at your last 3 answers.
what did you observe? I think the first one would be true. The values match the 68, 95, 90, 97. And then, shoot. You know what? We'll have to skip question 12 too. Let's go to 13. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that protein requirement will be normally distributed in the population of the United States. Protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.65. And the population standard deviation is 0.07. Question 13 is asking what proportion of the population have a protein requirement that is less than 0.60. Give your answer as a decimal accurate to 3 decimal places. Okay, this one we can use.
This doesn't look as difficult as the other 3.
No, it doesn't.
I feel like a lot of this math is like common sense, kind of, and like looking at graphs.
So area-wise, underneath the bell curve, I'm finding 0.243. Everything that's a z-score, like negative 0.6 and below is the area is 0.27, so 27.43%.
Yeah, that's what I got. Like 27.43.
Yeah, but I think we just have
okay. Yeah.
7.274.
Wait, so what would the answer be? Not 27.43?
Well, it says give your answer
Your
as
answer
a
is a decimal.
3 decimal places.
So
0.4.
Point what? Sorry.
0.274.
Okay.
Y'all good? Okay. Question 14 asks, what proportion of the population have has a protein requirement that is no more than 0.6? Wait 1 sec. Let me see this again. That is less than. Proportion of the population.
trying to do my online calculator and see.
Well, shoot. I'm confused now. Crap. No, let's stick with that.
What the heck?
Yeah, I don't understand.
Because I think the first question was asking 0.6, not negative 0.6. So I'm
Question
thinking,
13.
yeah, I'm thinking the area might be bigger. That we have to include the big part of the bell curve. So the answer really would be 0.7257 or 0.7256. And then question 14 would be 0.274. I think that's what it was asking. But
I mean, that sounds more of a logical answer. Like, so what I'm getting on my calculator is way off.
what do you mean?
Well, I think I just typed in the problem wrong is all.
Oh, how'd you figure it? Or like, how'd you work that one out?
Well, I was multiplying the bell curve by 0.60, but that's not right. I was just playing around with numbers.
Okay. Well, because we have to use the applet or whatever that is, I think, right?
I believe so.
Anyways, what it's saying, or what the answer is saying, is that a lot of people don't get their protein requirement, which is kind of ridiculous because there's a whole ton of meat in the United States.
I know.
But then again, it says good quality proteins. So that might be the reason.
So 13, we put 0.7256.
Yeah.
And then 14.274.
Wait, let me see here. So if the population standard deviation is 0.07 and okay, this is kind of weird. Let's think about this logically. So 0.65 is in the center, right?
Mm-hmm.
One standard deviation away would be 0.58 or 0.72. It's asking us what's less than 0.6 grams.
Yeah.
So what would 0.6 be in relation to 0.65 z-score wise or standard deviation wise?
Was that 0.05?
Yes, but standard deviation wise, like would we take the 0.05 divided by 0.07? You know what I mean?
I have no idea.
I don't know.
Here's my phone.
This is just like so crazy to me.
Yeah, can somebody pull up the readings or whatever that is? Let me check.
I'm looking at it now, but it's not really helping.
5 divided by 4. So the 0.6 is 1. Okay, let me try this really fast. Okay. That's interesting. I think that's more correct. Huh. So for the first answer, if oh wait, okay, 0.60. That's one less than the standard deviation. Okay, so I think I have this. I think I understand it. And let's see if I can explain this correctly to you. Does everybody have their normal probability applet on?
Yes.
Okay, so if you take 0.05 divided by 0.7, you get 0.714, which I'm thinking is the z-score. I'm not exactly sure, but I'm thinking that might be the z-score.
Okay.
Because that's the difference.
But are we supposed to be using with
Then
are we
whatever-
supposed to be using the applet for these questions?
to be honest, but it does help you find the areas in the z-score. But yeah, so anyways, I did that, and it seems about right because it's in the area where 0.6 would be, or rather the standard deviation. So it's 0.6 is 0.714 standard deviations away from 0.65. Does that make sense? Okay.
What question are we talking about? 13 or 14?
Question 13.
Okay.
So everything under 0.6 is the area, or rather the percentage is 23.76 or 23.8%, which I'm positive is the answer.
So you're saying the answer is what?
0.278, or rather 27%.
For 278?
Yeah. Now everything above 0.6 would be, the area would be 76.24%.
Okay.
Or 0.76. 0.76. Now, I'll submit my answers before anybody else does, just to make sure that that's right.
You don't need to do that. I don't want you to have to.
Well, it's good to know. That way we can still keep working on it. Otherwise, y'all are just going to get it wrong and then it's not work on it anymore because you have to go to work. So, anyways, so question 13, which I'm thinking is 0.278, and then wait, does that work? 0.237623. Oh, sorry. So 2376. 23. So 0.238.
For 13.
Answer. Sorry.
238?
Yeah. That one up.
So then are we doing like a similar thing for oh wait. Okay, wait. I was typing on 14. So question 13 is 238.
0.238. And then question 14 is the opposite of that, which is 0.762.
Is someone hitting their trackpad repeatedly?
Question 15. What proportion of the population has a percent that is less than 0.7? 0.7 would be the same thing. Wait, what? Why did they ask that? It's the same thing as 14.
Can you guys hold on just 2 seconds? I just have to go to the bathroom.
You're fine.
I'll be right back.
I'm pretty sure 15 is the same as 14. First of all, the routine environment is between 6 and 0.7.
I'm so confused, you guys. I'm sorry for like barely being any type of help.
I'm really confused myself.
when who was it? Allie or Andrea that left?
It was Allie.
Sorry, Allie and Andrea. You
Allie
look like
left.
really similar.
Andrea still here. Allie left.
Friend is 35th. All I know is that Andrea's married and Danielle's in Massachusetts and
Yes.
Allie is somewhere.
Somewhere.
Wait, was it Massachusetts? Sorry, Vermont, right?
Connecticut, but close to both. So I'm one state away from.
I'm going to Boston for my friend's wedding, so I was thinking Massachusetts in my head.
Where'd you serve your mission?
Me, Bolivia.
Oh, fancy.
Yeah, not really. Kind of the opposite of fancy. But...
Okay, I'm back. Sorry.
Okay, so going off of the same stuff that I was working on earlier, question 15 is the same as question 14.
Okay. Is the same answer?
It's the same standard deviation way, and it's asking for everything below.
Okay.
So just opposite sides. Question 16 is asking what's between 0.6 and 0.7.
Wait, do we have the answer for 15?
Yeah, it's 0.762.
Oh, okay, so that, okay. I just was.
Yeah, you're fine. Question 16 is asking for what's between 0.6 and 0.7.
Yeah.
Which the area that I found was 0.525.
Okay.
Yeah, so like 52.5%. And then I was on question 17, and I'm not sure how to find the 35th percentile for protein requirements for adults. Do you know what I mean?
Yeah.
So
And just go over the answers.
So what'd you say, Danielle?
I said at the end, can we just go over all answers again?
Yeah, that's fine.
So what would be the 35th percentile? Like, how would we find that out?
For the protein requirement for adults.
So, like, I know that the 35th percentile would be in the negative part. So it'd be like around, it'd probably be between -3 and -2, but I don't know how to find it.
I'm looking.
So 0 is 50%, right? Then would -1 be the 35%?
So in the lesson, there's a whole section on this, how to do this.
I think it's 0.67. So yeah.
How'd you find that?
Because it wants us to find the. Let me enter into my calculator.
Okay, looking online, I have 0.1% between -4 and -3, 2.1% between -3 and -2, and then 13.6% between -2 and -1. So you kind of just add those up as you go along, and then you figure out where the thing would be. You know what I'm saying?
Mm-hmm.
So it looks like it'd be somewhere between -1 and 0 is where the 35% would be. Sorry, and then was that you, Allie, that was saying that you like knew where to find it?
I don't know how I'm trying to figure it out.
Percentile.
What did you say that the answer was that you found? Because
0.67, but I don't know if that makes it 7%. If we're rounding it to the hundredths place.
Yeah, I'm just Googling it right now. So if you're given the probability percent less than x and you need to find x, you translate this. No, I don't care.
original equation.
I think the last two, I think it's 0.63 and 0.709 because I think that you like it has to do with the because it's asking where is it? So the 35th percentile, and so I think that we have to base that off of not the probability, but like the proportion of the population has the protein requirement. So I think that we like that.
What do you mean?
In the lesson, it says that you can use that normal probability applet thing
Okay.
when calculating percentile using a normal distribution.
So how would you use that to find the answer?
So there's an equation for it. It shows you exactly what to do in the lesson.
Yeah, okay, that's what I'm looking at now.
3.4,
Okay.
calculating percentiles.
So have you been able to calculate the percentile yet?
Yeah, I mean, you just put in, like, for instance, in this problem, it was 90%, and they put in 0.90 in the area. And then it calculated the, let's see. The z-score to give them a number, and then they use that to solve the problem. Let's see.
We still need to figure out 9 through 12, and I have to leave soon. $11:30.
Oh, man.
Hey, sorry, I totally missed what you guys are saying. So what were we just talking about?
We're still trying to figure out those answers.
Oh gosh. So we have 35th and 80th percentile.
Should we go up and try to do 9 through 12?
I'm
Because
looking at it now.
I do have to leave soon.
Okay. Number 9 is asking you to use the applet, so you have to click on that so you can use it. Z-scores will be between -1 and 1.
Would it be 0?
I don't know.
Do you think the percentile is just as easy as typing in the z-score as 0.35?
Well, there's an equation that you find after you do that in the textbook.
What do you mean?
Let me see if I found it.
From what it looks like on other charts that I'm looking at of normal distributions with the percentiles underneath, if you type in 3.5 on the applet, it looks to be exactly where it should be in comparison to these other charts.
Right. Yeah, I mean, that's what they did in this problem.
So I'm going to go ahead and go with that.
What are you putting?
I just put in the z-score as 0.35 as the percentile in the applet. Yeah.
On 9?
No, on 17, sorry.
Oh, wow.
Yeah. I thought we were working on 9.
I did too. Okay, what did you put for 17?
It's fine. Let's go back to 9. I don't know what I'm actually talking about, so. Okay, so the thing is that if 9 is 0, then all three of them are 0. Do you know what I mean?
Right, because it's the same question, just different numbers.
Yeah.
Right.
So suppose those z-scores come from the understanding question with proportions. So when it says proportion, is it just asking for area? You know what I mean?
I feel like it would say area though if it was.
Well, what's the proportion? So like what amount of the percentages would be between the z-scores? But then again, you also have those z-score tables too. You know what I mean?
Mm-hmm.
Let me look up one really fast. Or actually, huh? No, go back. Stop. So what percentage is between 1 and -1? Right, that's what it's asking. So the z-score I have here for 1 is 0.3413.
Point for number 9.
Yeah, and that's from 0 to 1. Does that make sense? So
What did you put?
from 0 to 1, or rather from 1 standard deviation, like 0 to 1 away, positive, it's 0.3413, which I imagine it's the same negative. So let's just say it's 0.3413 times 2. That's 68%, right?
I'm getting 0.683.
Yes. So it would be around 0.683. It'd be 0.6826.
Okay. So you'd round that to 0.683.
Yeah. So does that work out okay?
Yeah, that actually makes sense.
Okay.
Like the
What
only
number is
thing
it?
that's made sense to me this whole time.
So the z-scores between -2 and 2, that would be, add on another 13. Sorry, one sec. -2 and 2. So area in between that, I have 0.9545 or 0.955.
On 10,
Yeah,
I got 0.955.
0.955. Question 11. I think it's like gonna be 97 point whatever. .9973 or 0.997.
And then 12, it's A. The value matches the 68 to 95 to 99.7 rule.
Exactly. Although technically 95.5 should be rounded up to 96, but yeah. Let's go back down to 17. Yeah, we're gonna have to use a formula to find that out. Did somebody say that they found that?
I got for 17, 18, I got 0.623 and 0.709.
3.623 and for 18?
No, for 17, I got 0.623 and 18.709.
What do you mean by that?
Like that's the answer.
Well, you put in 0.623 and?
No,
for 18,
17 I put 0.623 and for 18 I put 0.709.
Okay.
So
Which is okay, so I'm wondering here.
Here, I'm gonna submit them because I have to go to work in like just a second, and I'll tell you if they're right, and then you guys can,
Yeah.
I'll take the fall this time. Well, it looks like you guys we got 100%.
Really?
Yes.
Seriously?
Yes.
Okay, can you go over all the answers for me, please? Over.
Yeah. So, 1 second.
Very cool.